when you're graphing linear functions, there are two things that, well, really three things that you need to pay attention to. The first thing you need to pay attention to is your equation already in slope-intercept form? If yes, you're good to go. If no, you need to put it in slope-intercept form. Which again is that y equals mx plus b. So is your equation in slope-intercept form? If yes, keep going through these steps. If no, put it in slope-intercept form first before you continue on. Now, when you actually get to the point where you're graphing it, the very first thing you have to plot on your graph is your y-intercept. Yes?
If you're just talking about rate of change, why does a y-intercept have to be specific? Because can't you have multiple different y-intercepts of lines with the same rate of change?
Not a linear function, you can. It has only one y-intercept. Because it's a straight line that goes on forever and ever and ever in opposite directions, you're never going to cross the y-intercept more than once.
But couldn't you have multiple different lines?
But we're talking about one specific line. Yes, different lines will have different y-intercepts. But if I'm talking about one line, it only has one y-intercept, and it has one rate of change or one slope that you use consistently. Make sense? Okay. So you're going to plot your y-intercept on your graph first. Why do you think I'm going to plot that first? What do you think it is? It is very important. It also represents our starting point, right? That's where we start from. Knowing that it represents your starting point will be especially useful when we start doing word problems, because you'll need to know in that problem where it starts from. Then you're going to use your slope or use your rate of change to plot additional points on your graph to create your line. To plot additional, oh, thank you. Plot additional points on your graph. Thank you for catching that. I think as I wrote that, I said the word line, but meant points. Okay, so use your slope or your rate of change to plot additional points on your graph to create your linear function. Now, you always want to make sure, in addition to that, that you label your line with your equation. Okay, so you do want to label the line with your original equation and put arrows on it to show that it goes on forever and ever. So yes, you're going to be doing what you've heard called rise over run. But we're not going to use rise over run because rise over run also comes with a set of particular rules that you'd have to follow and memorize, and that just doesn't make sense. So we're going to use what we knew about similar triangles to help us with the slopes. So after you've got this down, go ahead and put example 1 and glue one of your graphs in there so that I know you are ready to move on. So once I see those graphs in there, I know that we're ready to go. You got it? By the way, I missed you guys yesterday. Alright, does everybody have this graph glued in? Sweet. Okay, so I have the equation y equals 4x. Let me ask you, is this already written in slope-intercept form?
Yeah.
How do you know?
Because y is by itself.
Y is by itself and equal to something. So before I graph this, though, I need to identify my slope and my y-intercept. I want to go ahead and get that out of the way so I don't have to try to play that game later to figure out, oh, I don't know what that is. So what is the slope of this line? 4. And how could I write that as a fraction so that I have change of y over the change of x? Luke? 4 over 1. Because remember, slope and rate of change is all about change over y over change over x. So I'm going to kind of change that into a fraction. And what's my y-intercept? Kyla? Think about where y-intercept is in our equation. Clay? My y-intercept. Remember, y equals mx plus b, where b is my y-intercept. 0. If I added 0 to this, is it going to change the value of my equation? No, so my y-intercept is 0. So what does that tell me about the type of line I have? Is it proportional or not? Aubrey?
Yeah.
How do you know it's proportional?
Because it's going to make a straight line.
That doesn't necessarily tell me it's proportional just because it makes a straight line. Josie, help her out. It has a starting point from 0. Okay? That's how you know it's proportional. So, if my y-intercept is 0, where am I going to plot my first point? 0, 0. So I'm going to put a point right there. Now, is my slope positive or negative? It's positive. So I know my line's going to point, quote unquote, in which direction, Hunter?
To the right.
It's going to point towards the right. Okay, so if it doesn't, I've done something wrong. So if I have a slope of change of y of 4, change of x of 1, and I'm going to start here, Do you agree with me that my change of y, 1, 2, 3, 4, over my change of x, 1, is accurate? What if I went in the opposite direction? What if I went 1, 2, 3, 4, 1? Could I plot a point here?
Yes.
Why? Why? I went negatives. I had a negative change. Why can I still do that? Why is that okay? It's equivalent, but why?
Because it's still a change in y over a change in x, and they're both negative.
And what do we know about two negatives?
They make equal.
They make a positive. So they are equivalent in the fact that 4 over 1 is the same as negative 4 over negative 1. So was I okay to do that?
Yes.
Absolutely. So now I have this point. From this point, I'm going to go 1, 2, 3, 4, 1. Is that still okay?
Yes.
If I made a right triangle right here, does the change 8 over the change 2 still reduce to 4 over 1? So am I still okay?
Yes.
And can I go in the opposite direction? Yes. So, from here I can connect all my dots. Oh man. Draw my arrows to show that it goes on forever and ever in each direction. And also label my line. Because when you get to a point that you're doing systems of equations or inequalities, having your lines labeled will be a huge help to you. So go ahead and get in that habit now.
That line's not straight.
Is it close enough?
No.
No? So have I successfully graphed this line?
Yes.
Yes. Do I have a y-intercept of 0, 0?
Yes.
Okay, cool. And do I have a slope of 4 over 1? And are all of my points equivalent in the fact that they have the same slope?
Yes.
Yes. Simple, right? Not too bad. Not too bad. Let's do another one. Oh, and I graphed it and put my arrows. I did all my stuff. Okay, so I've got another graph here. All right, let's look at one that has a negative slope. Oh, you can't see that, I'm sorry. All right, so my second example is going to have the equation y equals negative 3 over 2x plus 5, or negative 3 halves x plus 5. Is this already written in slope-intercept form? How do you know? Y is by itself and it equals something where you have that slope-intercept form. Sweet. So I don't have to change anything. I don't have to put it in slope-intercept form. My life is a little bit easier. What is the slope of this line? Valerie? Negative 3 over 2. So what's the change of my y values? Looking at my slope, what's the change of my y values? Huh? Negative 3 or 3. And what's the change in my x values? 2 or negative 2, depending on what you're change of y was. Okay, cool. What's my y-intercept? 5. Positive 5 or negative 5? Positive. So where do you think I'm going to start with this equation? 0, 5. Why didn't you say 0, negative 5? You're correct. What makes it correct? Why didn't I put it 0, negative 5? Clay, help him out. Why didn't he say 0, negative 5? The y-intercept is positive. What if the y-intercept was negative 5? Would my starting point be 0, negative 5?
Yes.
It would. But in this case, it's not. So I'm going to go all the way up to there, 5 on my y-axis, and plot my point. Now, if this has a negative slope, which direction will my line point? Kyla? It'll point to the left, right? I know that negatives kind of quote-unquote point to the left. So, I've got a negative change. What do I know about negatives? Tell me what you know about negatives and when they're being divided.
Negative divided by positive is a negative.
Negative divided by a positive is a negative. Okay, so now let's think about what we talked about Tuesday about negative slopes. As one value, the other value decreases. So, if I wanted to plot a point, and I were to increase by 3, 1, 2, 3. If I want this to be negative, I need to now decrease by 2. 1, 2. Plot a point. I'm increasing by my y, which means, Sebastian, I need to decrease by my x's. Make sense? As one increases, the other decreases. So what if I wanted to put points in this direction, and I started by decreasing by 3? I need to increase by 2. And can I do the same thing again from this point? Decrease by 3, increase by 2. Decrease by 3, increase by 2. And could I keep going on? I could, but do I have enough points to graph my line confidently? Yes. Draw my arrows to show that it goes on forever and ever in each direction. And then what else do I need to do? Label it. And this one was negative, so as one increased, the other needed to decrease. And if one decreased, the other needed to increase. And then if something was positive, something increased as the other value increased, or they both decreased. Right? 2 negatives make a positive. Are we okay with that? How many of you guys think you're kind of getting the hang of it so far, even though we've only done 2? Like, you're kind of getting there. Okay. I want to give you an example. I'm going to give you 2 examples that I kind of want you to complete for homework. Come tomorrow so we can go over it. Okay? The first one will be y equals negative 4x plus 7. So that'll be one example.
What is it? Can you go down a little bit?
Oh, I'm sorry. And the other one, they want to make you do a little bit of legwork on it. So this is 4 plus 8x equals 2y minus 2. I want you to do those 2 examples tonight so we can go over them tomorrow. I want you to try them out. Even if you don't think that it's 100% correct, I want you to have at least something. Okay? We'll do the other 2 examples if we need to at the start of class tomorrow before you do your activity. I will be posting this on our Canvas site today after school, so you can refer back to it. I will shoot you an email when I have it posted. Everybody cool with that? All right, after you've got this written down, see you tomorrow. Keep your extra graphs. Keep your extra graphs.